Okay, so absolute value equations. Example number 1. The absolute value of x equals 5. If I could make this box, there you go, okay, and put it over that, and ask a kid, hey, what could go in place of my smudge mark such that the answer becomes positive 5 when you take the absolute value of it? What would you tell me are possible solutions to put inside the absolute value bars? Hetty? Yep, 5 is 1, or Sam? Or negative 5. Are there any others? No. So 2 solutions. All right, so good. So in other words, you're going to do this. You're going to say x could be positive 5, or x could be negative 5. Notice I've dropped the absolute value bars, and I have 2 solutions now to the equation, 5 and negative 5. Sometimes in algebra we do this. You might see that more and more as you go into your higher level math courses. Pete, shut that door for me. We call that plus and minus 5. It means positive, negative. We pronounce it plus or minus 5. There are 2 solutions to that equation. All right, now let's kind of transition to equation number 2. All right, write down x minus 10 equals positive 4. Let me see if I can use that box again, or smudge mark. Okay. What could you put in place of my empty box such that the answer is positive 4? Pretend you have no idea what's behind the box. Just give me some numbers. Luke?
14.
What?
14.
No, the absolute value of 14 is not 4. Betaket.
4.
The absolute, okay, 4 is 1. So 4 is one answer key. What else could you put in place of there? And you say the absolute value of blank equals positive 4. Keegan? Negative 4. So I'm going to go back now. Erase that smudge mark. And what did I say? X minus 10? Yeah. So now x minus 10 can either be positive 4 or it could be negative 4. So you set up 2 separate equations and then solve them using algebra. All right, we know what to do for the first part. Add 10 to both sides. And that's where your 14 came from. Or over here, add 10 to both sides. And here's 6. So we have 2 solutions. We have 6 and 14. You don't have to put them side by side like I did. But I think the word or plays an important part here. You can't say and, because you can't put them in at the same time. You're saying you either use 14 or use 6 as your solution set. And that's where I'm getting at right now, guys. All right, number 3. Write down the phrase, 3x, the absolute value of 3x minus 2 equals 10. And that's how the game goes. Imagine you don't know what's inside the box. That's why I keep drawing my box. And if I were to just shade it in so you couldn't see it. And then I would ask you, the absolute value of what equals 10? What are the 2 solutions, what are the 2 things that could go in place of the absolute value bars to get back a positive 10? Better, okay, give me one of them.
Negative 10.
Negative 10, or what's the second possible one? Alil.
Positive 10.
Or positive 10. So I can go back now and say, okay, well, hold on. We said 3x minus 2 could be negative 10, or the 3x minus 2 could be a positive 10. Now you have 2-step equations on both sides. Let's see, add 2 to both sides. You get 3x equals negative 8. Well, this will not be a nice answer. And then divide by 3's. Let's just change this into a mixed numeral. Negative 2 2/3. Hey guys, I'll be honest here. We've come to a point in time right now, the algebra books actually don't change it to negative 2 2/3. They keep it at negative 8/3, and I'd be okay with that. I guess I got to follow the lead. So I'll be okay if you guys don't reduce it to negative 2 2/3. Other side. Add 2 to both sides. Oh, this will be nice. Then divide by 3. And there's your 4. So one or the other is going to work. Either use -8/3 or use +4. Come on, wireless, kick in there. Come on, wireless, kick in to put the 4. There we go. So one or the other is going to work. That's what we're doing right now. It's a pretty easy setup. You split it into 2, and you drop the inequality signs. Hey, don't be doing this. Every year I see this on a test or a quiz. Hold on, let me change my ink. I see kids doing this. Don't do that when you break it up. You're all done using absolute value when you put down the 10 or -10. So don't put the bars back in any longer. So -2 2/3 or +4. Or speaking of 4, how about the fourth one? All right, 2x minus 4 equals +8. I think you all know what to do by now. Okay, inside the brackets, ignore the 2x minus 4, and your brain says, okay, the absolute value of what equals 8? Well, you could put in -8, or you could put in a +8. It's kind of elementary-ish here. And then, of course, I will say it, but I'm not going to show the work any longer. I think we've hit that milestone. Add 4 to both sides. So 2x equals -4. Then divide by 2, -2. So one of your solutions is -2. Other side, add 4 to both sides again. 2x equals 12. Now divide by 2, 6. So you can say, well, you can either use -2 or +6. I promised you 5 examples, and 5 examples is what I'm going to give you. Anything I can clarify before I do my very last one here? The last one is like the oddball one. It's pretty simplistic. All right, number 5. This is the weird one, which might happen every now and then. They're going to try to catch you off your guard. All right, a crazy one. 4x minus 9 inside the absolute value signs equals a -1. All right, why don't you solve that before I'm done? And I'm going to hit pause on my screen here. Okay, if I made the absolute value bars and put a question mark in between and said what goes inside of the absolute value bars, I get -1. Nothing does. Okay, so because there is nothing, you don't even break it up. Since there is nothing that can go in place of the 4x minus 9, there is not going to be a solution. So here is the rule. When your problem equals a negative number, don't bother doing it. Just say the phrase, no solution. You would be surprised how many kids do all the work out just like you did, and you guys have something like 5/2 and whatever it might be, or 2. So be on the lookout. When it equals a negative number, then it cannot be done, because absolute value is a distance from 0, and you can never have a negative number be a distance from 0. Right, so there's that lesson plan right there.